All right, so yesterday we spent the majority of the class talking about looking at exponential functions, growth and decay, as well as looking at how to write some of those functions. And I told you guys at the end of class, or the end of my second micro lecture, that you're going to eventually have to solve some of those equations, solve some of those functions. And in order to do that, you need to be introduced to something brand new that you've never seen before, which is a logarithm. All right, now this logarithm, there's a lot of stuff here you've already read. The most important thing that I want you to think, when I say the word logarithm, you want to think it's just an exponent. That's it. All right, so I have this equation up here that says 2 to the x power equals 8. And you guys probably already know the answer to that, what value for x makes that true. But in order to solve that, showing all the steps, you need to be able to use a logarithm. So I'm going to show you another example that you've already seen. 2 times x equals 8. All right, and so when you learned how to do this, probably in pre-algebra, you learned that in order to get rid of that 2, you need to do the inverse operation. In this case, the operation is multiplication, so the inverse of that would be division. So that's why you divided by 2 to isolate x, to solve for x. All right, so that's something that you know how to do. In order to solve this one, which we will do later on this week and next week, you need to know how to take the logarithm of both sides. So again, that is the inverse operation of solving for an exponential. So logarithm, just an exponent. So I'm going to show you the two forms that we're going to be working with today. We have the exponential form, which we spent a good amount of time on last class, and then the logarithmic form. Again, this is something new. You've never seen this, and this is read as the log base b of a equals x. All right, so we'll be talking about how to say that correctly, and we'll be talking about how going back and forth in between these forms. So we can actually take any exponential equation and write it as a logarithmic equation and vice versa. All right, so that's what we're going to show you right now with these first couple of examples. So in letter A and B of example 1, they're both written in exponential form, and we want to write them using a logarithm. All right, so I'm going to write the word log. Again, you always want to think about how you're going to say it. You're going to say log base b of a equals x. Well, my base is 9, so you want to kind of write that as a subscript, so kind of a little smaller. And then of 81 equals 2. Again, the reason I harped on understanding that a logarithm is an exponent is that your logarithm should always be equal to, you guessed it, the exponent. So notice the 2 is the exponent, so that's what is after the equal sign. So that's how you can do a mental check to make sure you did it correctly. Let's try this other one. The log base 5 of 0.04 equals negative 2. All right, so that's going from exponential form to logarithmic form. Again, my exponent is negative 2, so that should be after the equal sign. Now, you can always go the other way. You can always go from logarithmic form to exponential form. All right, so I'm going to show you how you can write it using just what we talked about with the log base b of your exponent, or excuse me, of your value equals your exponent. So we have our base is 12. What is the exponent? It's always after the equal sign, so 2 equals 144. And you should be able to do a quick mental check to make sure that makes sense. So 12 squared is 144. But the way that a lot of students like to think of it, it's a little easier. And again, I'm not saying that this is an actual mathematical thing, but it helps students remember. It's something that I'm going to call swoop, all right, or using the swoop method. Again, I'm saying swoop, like Cheryl Swoops, Houston Comets, probably don't remember that. Good times, championships. All right, so you're going to start at the base, which is 1/2, and you're going to swoop around. All right, so it's 1/2 to the negative third power equals 8. So 1/2 to the negative third power equals 8. Again, it's not a mathematical term, so you are allowed to use it, but just understanding that if I ask you, hey, what does swoop mean? You keep saying this word, that you need to tell me that it's how you go from the logarithmic form to the exponential form. All right, so I'm going to let you guys try these at your boards right here. I know there's a lot of them, but I'm just having you change forms So it shouldn't take you too long, and your teacher will come around and tell you if you are correct or not. All right, good luck.